Hi guys, this is O-level chemistry, paper 11, June 2020, question 11. The dot and cross diagram for four compounds are shown. Which diagram is correct? Note that only the outer shell electrons are shown. Okay, so in A, we've got a carbon forming four single bonds with four different hydrogen atoms, forming the structure of methane. This looks correct. Next, we have a carbon-carbon single bond and each carbon atom with two hydrogen atoms covalently bonded to it. So there is a missing bond. So B is incorrect. In C, we've got a carbon double bond, an oxygen double bonded to carbon double bonded to oxygen. But each oxygen has a lone pair of electrons on it. In fact, in carbon dioxide, there were supposed to be two lone pairs of electrons present. So this makes option C incorrect as well. Option D, we've got an HCl molecule with chlorine having three lone pairs of electrons present. Because chlorine belongs to group 7, it has 7 electrons in total, which is correct. However, there are additional electrons present on hydrogen. Hydrogen belongs to group 1. Hydrogen cannot have any more electrons in its structure. So this makes option D incorrect as well. So as a result, the correct option for this question is option A. Question 12. Element X has a lattice of positive ions and a sea of electrons. So this is basically the lattice of a metal. Which property will X have? It conducts electricity by the movement of ions and electrons. No, ions will not move in metals. Electrons will move. It has a high melting point. Yes, metals have high melting points. It is decomposed by electric current. No, it will conduct the current. It will not get decomposed. It is not malleable. Metals are malleable elements. So the correct option for this question is option B. Question 13. A chicken egg has a mass of 60 grams. The eggshell is 10% of the total mass. The eggshell is made of calcium carbonate. What is the mass of calcium in the eggshell? So first of all, 10% of 60 is equal to 6 grams. This is the mass of eggshell. So in calcium carbonate, we have 1 mole of calcium present. That means the MR of calcium carbonate would be 40 plus 12 plus 48, giving us a value of 100. 100 grams would contain 40 grams of calcium. In the eggshell, we have 6 grams of calcium carbonate present. So how many grams of calcium would that contain? This would be 6 upon 100 into 40. This will give us a value of 2.4 grams. So based on this calculation, the correct option for this question is option C. Question 14. Ethanol can be made by the reaction shown. So we have C2H5Br plus NaOH producing ethanol and NABR. Okay. So if 5 grams of C2H5Br produces 1.59 grams of ethanol, what is the molar percentage yield of ethanol? So for this, we need to find the molar yield of ethanol. So in this case, the MR of C2H5Br is 109 and this produces 46 grams of ethanol. So this is 100% pure. 109 grams would produce 46 grams. So 5 grams should produce how much? This will give us the amount of ethanol when 100% yield is obtained. So 5 divided by 109 multiplied by 46 will give us 2.11 grams. So this is when there is 100% yield of ethanol. Now, they have said that 1.59 grams of ethanol have been obtained. So 1.59 grams of ethanol means 1.59 are produced. However, 2.11 were supposed to be produced. So this into 100 will give us the percentage yield of ethanol. So this gives us a value of 75.35%. Looking at the options given, this makes option D the correct option for this question. Question 15. An aqueous solution contains 0.01 moles of Zn2 plus and 0.01 moles of Cu2 plus aqueous. Aqueous sodium hydroxide is added until in excess. Okay. After shaking, the mixture is filtered. What remains on the filter paper? Okay, remains on the filter paper. An aqueous solution containing this aqueous sodium hydroxide is added until in excess. So zinc will dissolve, forming a colorless solution, but copper will form a blue precipitate which will not dissolve in excess. Okay, so we are left with, and the precipitate would contain all the copper because sodium hydroxide was in excess. So this would contain 0.01 moles of copper hydroxide. Okay, A, white hydroxide and blue hydroxide, no, white will not be there, right? A and B are not the answer. C contains 0.01 moles of blue hydroxide, which would be copper hydroxide, yes. And D states no solid residue, no, copper hydroxide would be present. So this makes option C the correct option for this question. Question 16. Which arrangement is used to electroplate copper onto steel key? Okay, in order to electroplate copper, the electrolyte must contain copper. So A and B have the correct electrolyte, C and D have been eliminated. Now, the anode must also be made up of a pure copper plate because this copper will undergo oxidation and copper will be converted into Cu2 plus ions, which will be deposited in solution. And at the cathode, this copper 2 plus ion will reduce on the steel key and coat it with copper metal. So anode should be made of a copper plate and the cathode should be the steel key. So option A has anode as the copper plate and cathode as the steel key, while option B has the anode as the steel key and the cathode as the copper plate, making option A the correct option for this question. Question 17. The rate of reaction is between calcium carbonate and hydrochloric acid is measured in three separate experiments. And the experiment has a weighing balance over which a conical flask is kept and the loss of CO2 is measured in the form of decrease in mass. Okay. In experiment 1, the calcium carbonate is powdered and an excess of hydrochloric acid is used. Okay, calcium carbonate is powdered, excess of HCl is used. Okay, all of the calcium carbonate will be used up. In experiment 2, the calcium carbonate is lumps and an excess of hydrochloric acid is used. All of it will still be used up, but more slowly, not as quickly as the first experiment. So the mass uh, would be the same, the decrease in mass obtained would be the same, but it would be decreasing much slowly than in experiment 1. Okay, in experiment 3, the calcium carbonate is in lumps, but insufficient hydrochloric acid is used. Okay, if there is insufficient hydrochloric acid used, that means not all of the calcium carbonate will be used up, so loss in mass would be less. So X represents experiment 3. Now between Y and Z, Y shows that the decrease in mass is more quicker than in Z, which means in Y we would have had powdered no. Decrease in mass is slower because it takes more time for the mass to decrease. Y has a slower decrease in mass. So in this, we would have had the lumps, which means experiment 2. So the decrease in mass in Z is the quickest because more mass has decreased in lesser time. So Z corresponds to experiment 1. So we have identified which curve corresponds to which experiment. Now, which statement is correct? Experiment 1 is shown by curve X curve X is for experiment 3. Experiment 1 is shown by curve Y. Curve Y is for experiment 2. Experiment 2 is shown by curve Y. Yes. Experiment 2 is shown by curve Y. And experiment 3 is shown by curve Z. No. Curve Z is for experiment 1. So this makes C the correct option for this question. Question 18. Pieces of zinc are added to aqueous copper sulfate. Okay. Which statement is correct? Copper 2 plus ions is oxidized to copper? No, it is reduced because copper has a oxidation state of 0. Plus 2 to 0 is reduction. B. Copper 2 plus ion is reduced to copper by losing electrons. It is not by losing electrons, it is by gaining electrons. Okay, zinc is oxidized to zinc 2 plus? Yes. By losing electrons? Yes. And zinc is reduced to Zn2 plus? Wrong. So the correct option for this question is option C. Question 19. The oxide of element X reacts with acids to form salts. Okay, if it is reacting with acids to form salts, so this should be a metal oxide because metal oxides are either basic and in the case of aluminum it is amphoteric, but it will still react with acids. Okay, which statement about element X or its oxide is correct? X conducts electricity. Yes, metals conduct electricity. X is a non-metal. No, X is a metal. The oxide in a gas at is a gas at room temperature and pressure. No, it is a solid. The oxide is covalent. No, it is ionic. So option A is the correct option for this question. Question 20. Nitrogenous fertilizers promote plant growth and crop yield. Which compound contains the greatest mass of nitrogen in 100 grams of the fertilizer? Okay, so first we need to find out the molar masses that is present and then compare it to 100 grams of fertilizer. So in the case of KNO3, its molar mass would be 39 plus 14 plus 48, which gives us 101. So 101 grams contain, there is just one nitrogen atom, so 14 grams of nitrogen. So 100 will contain roughly around 14 grams of nitrogen, roughly, not exactly. So the answer is close enough to 14. Okay, B. Now here we have two nitrogens, so 28 and 4 hydrogens and 3 oxygen makes it 48. So we have a total of 80. So 80 grams contains 28 grams of nitrogen. So 100 grams will contain how much of nitrogen? So this would be 100 upon 80 into 28. This will give us 35 grams. And just to be clear, in the first one, I didn't perform the calculation because the calculation would have been 100 upon 101 into 14. So it's like 100 upon 101. This will not change from 14 a lot. It will be close enough to 14. So that is why, because this is a multiple choice question, I left out the calculation. So roughly around 14 or less than 14. Okay. In C, we have got two nitrogen atoms. So 28, 8 hydrogen, 1 sulfur, and 4 oxygen. So this gives us a total of 132 grams. So 132 grams contains two nitrogen atoms, so 28. Therefore, 100 will contain how much? This will be 100 divided by 132 into 28. This gives us a value of 21.21 grams. And the last one, ammonium hydrogen phosphate. This will have two nitrogen, so 28, 9 hydrogen, 1 phosphorus, and 4 oxygen. So this gives us a total of 132 as well. So 132 grams will contain, there are two nitrogen atoms, 28 grams of nitrogen So 100 grams will contain how much? So this value will be the same as the value obtained for option C, which is equal to 21.21 grams. Therefore, the question has asked which compound contains the greatest mass of nitrogen in 100 grams of fertilizer. The greatest mass of nitrogen obtained is 35 grams in option B, making option B the correct option for this question.